Okay. Test. Hello. Hello, everyone. Woo! That's right. It looks like we have a pretty crowded room here. I guess I don't actually see that many empty seats, so there's actually a pretty good. I see like one or two right there. But thank you very much for attending our session on Project Tango. My name is Johnny Lee. I'm the project lead for the project, and I'm here to give you just sort of a background on what the project is, give you an update, and then talk about where we're headed with it. Just so I know, how many of you knew about Project Tango before Unite? Oh, okay, that's about half of you guys, so that's good. Hopefully more of you have learned about it. We tried to set up a nice booth for you guys and tried to set up a nice game and even give people an opportunity to win a dev kit. Yes. Just curious, how many of you guys did play a game and actually got a dev kit? Okay, also about half of you guys. All right, so maybe it's the same half of people, we don't know. So anyway, sort of philosophically, the background of what we're trying to do is that if you think about the mobile devices that permeate our lives today, the software that we write for them, for the most part, view this as the boundary of the world, right? The square, the rectangle, these pixels are what your app typically assumes is where the world ends with respect to the user. But our environment plays a really big role. Whether or not we're at home, in our kitchen, we're at work with our colleagues, we're in classrooms or at school with peers in a lecture hall, or we're relaxing at home, either by ourselves or with friends. That the boundaries of our physical lives is much more than simply what's contained in these dotted lines. And so our belief is that where we are and what's around us dramatically shape our lives and our general behavior. And it's important that we believe that our devices eventually have this same sense of understanding that we do. So the goal of Project Tango is to give our electronic devices, our tools, our computing devices, and ultimately our wearable devices at some point, a human scale understanding of our physical space in motion. And what do I mean by that? So we all use our vision system, this immense tool that we have that allow us to process information about our environment. We know roughly how big this room is. We know where we are in this room. We knew how to get to this conference center, to this particular room, all using our vision system. And it's an incredibly powerful and evolved sense of perception that these devices simply don't have today. So what a Project Tango device has are the hardware and software to do this. So if you were lucky enough to sort of win a device, you actually have one of the most powerful Android devices that exist today. It has a Tegra K1 processor, 4 gigabytes of RAM, 128 gigabytes of storage, and it has more sensing than most robotics do. It has a depth sensor, a motion tracking camera that has a wide field of view camera, and it has carefully time-stamped gyro and accelerometer data. And the reason why we put all these sensors together is so that we can capture both an accurate sense of physical motion as well as the environment. So we're happy to say that we've been distributing the devices over the past few months, and we're starting to sort of ramp up our distribution of these. We've had over 4,000 developer kits distributed in the hands of app developers and game developers around the world. There's 3 rough categories that we're starting to see good traction for applications of the technology. One is navigation, the other one is gaming, and a third category which we broadly call utility. So first of all, in navigation, basically we're talking about a better blue dot. When you use Google Maps today, you use your phone, you can navigate to your favorite restaurant or even to a new office building. But once you get to that building, GPS starts to stop working, as well as when you get to a shopping mall. And there are attempts to use Wi-Fi and Bluetooth beacons. Some companies are doing magnetic-based tracking, all in an effort to give you indoor-based positioning. But unfortunately, there's still lots of caveats associated with those technologies. And what we want to do is use the vision sensing technologies to not just say, you're in this part of the building, but you are 3 feet 4 inches from this corner of the hallway. In fact, the tracking positioning is good enough that we can not only provide indoor walking directions, but we can actually start doing AR-style overlays of turn left or turn right at the end of this hallway. For those of you who saw our demo show on the floor, you probably saw these Nerf Guns. This is a slight partnership with Hasbro, where we're looking at using the tracking capabilities to basically provide you a magic window experience, where you can place the phone on top of a Nerf gun and then run around your house or run around the expo floor using the tracking technologies. Now the demo on the show floor is restricted to a wall, but that's largely because we haven't quite got the engineering team to take over the whole expo hall. But well, hopefully we'll do that at some point. We've also started working with a few of you guys from the Unity community, people with really great assets who have these great games which are top-down, which actually are Tango enabled very easily. I'll give you a demo of this later on the talk, but we worked with Possible Games, and they have a quick demo of Poco Echo, which is a sort of a music-based puzzle game, and you use your tablet as sort of a first-person camera to explore the environment. Elemental Studios has this really nice assets for doing essentially a virtual showroom for a bicycle. This one I'll also demo for you on stage, where you can place this AR bike in front of the device. So we had a workshop a few months ago coming up to Unite, where we invited several people who are from the Unity community to see if they could Tangofy their apps. And we brought them on site for about 2 or 3 days. And within the first day, they had the basic integration working and spent the next couple of days sort of polishing it up. So it only takes a few hours to actually take any existing asset you have and enable the 6DoF controller that we provide as a Unity prefab. Some of you, I actually forgot if we ran out of these headsets, but one of the other things you can do with the Tango headset, while admittedly clunky right now, is you can put it in a plastic head mount and put it on your head and use it as sort of a 6DoF VR headset. Now, we'll be the first to admit that the Tango devices don't have all of the nice low latency rendering stack that the Samsung Gear VR is, but they have the tracking capabilities that allow you to get up and walk around without any constraints. If you get one of the tablets and you go to the Play Store, you'll find a couple of very simple VR-enabled Tango VR apps that you can test and download. This is just some existing assets from Befio that actually I took and put in the Unity prefab, and you can then crouch down to look at all the villagers with the device. So Tango has 3 core technologies that sort of summarize all the different functionality. We have something called motion tracking, area learning, and depth perception. The first, which is motion tracking, is something very analogous to a 3D mouse. When you put your mouse on the table and you move it around, you get these delta coordinates that essentially integrate up to the position or movement of the user's hand. The tablet does exactly the same thing. When you first run motion tracking samples from our Unity sample code, what it basically does is it gives you an offset position from when your app started. So if I turn on my app here and I walk this way 5 meters, it'll show 5 meters in the X coordinate. So this is essentially a delta position from when you started your app. The second capability our devices have is something called area learning. And this one's a little more complicated because it requires you to think about the spatial memory of the device. So if you were to imagine closing your eyes today, right now, you would remember roughly where the room is, how big the room is, and how you got to this room. And that memory is basically this area learning, so that when you come back to this auditorium tomorrow, you'll understand you're in the same place that you were yesterday. And that's basically what area learning allows you, is to allow you to store the absolute persistent location of the device in someone's home. The third is called depth perception. And we have an integrated small depth sensor. This is somewhat similar to a very miniaturized version of the Kinect, but we actually have an infrared projector that allows you to measure the distance to walls and floors and surfaces. And this allows you to capture the geometry. So it allows you to have characters hide behind your couch or jump on top of your table, or balls to bounce off the walls. So let me just show you a video of some of the capabilities we have today. As an early prototype, he strapped it to his head. Here's an example of area learning where we're registering existing points onto existing surfaces. So really, really neat stuff. And the fact that it's all working, it makes it even cooler. Okay, so let me show you some demos in real time on the actual same kind of devices that our dev kits are. So if you want a device today, if you go and download some apps or you follow our sample code, you'll be able to see results just like this. So let me start off with the basics, which is the motion tracking. And the technical term for this is odometry. So what you see here is the image from our fisheye camera, and this allows the device to see most of the room. And if you think about how we as humans understand our physical motion, our ego motion, we use our peripheral vision a lot. And so this is essentially peripheral vision for a mobile device. Like a lot of mobile devices, we have gyro and accel. So when I turn the device left and right, you'll see the turquoise frustum in the upper right turns just like as though I was turning my phone. But what's unique about Tango devices is that what I can do is actually move the device in a circle, and it continues to track that motion. And if I walk over to this side of the stage or walk to this side of the stage, I can even run back and forth. Right? And it continues to track my motion in real time. The graph you see at the bottom is actually from the back. So if I move the device up, move it down, or if I just shake it up and down and make zigzags, we're getting full 6-off coordinates at 100 hertz. And so you can use this inside your game to basically drive a new user experience. So this is a homage to a pretty famous world-building app. Okay. And basically all I've done is I've just used motion tracking as my camera controller. And so all I do is I pick up this cube menu, and let me lay down a foundation really quick. Building blocks. Oops, I missed some points. And I'm just using the tablet in physical space, just pointing at the ground telling the device where to place objects. Okay, let me add some pillars for windows. You can tell I've done this before. Okay. Bop, bop, bop. So you can actually see it was pretty quick to build this little house. Here, actually, let me make a nicer looking house than usual and add a little roof like this. Okay. So what's kind of neat is that this structure kind of exists on that part of the stage. So when I walk backwards, I can look at it from a distance. And if I want to, I can actually, whoops, I can go inside the house, crouch down, and put in some furniture. So the neat thing about this is that this was very, very easy to do with the motion tracking of Tango. In fact, building the game took probably 10 times longer than it took to actually get the controller data into the game. You can also imagine making this a multiplayer experience where multiple of us are in the same physical space, either building castles together or competitively tearing them down. Let me show you some demos using the depth camera. So that was just using the motion tracking capabilities where it tells you your delta position from frame to frame. But one of the things we have is a sensor that tells us how far things are. So if I want to measure the length of the stage, I just click on that tab and you see that little yellow marker. It tells me how far that marker is. But if I walk over to this part of the stage, I can drop an anchor here, and it tells me that's 24 feet long. Let me see if the depth sensor will reach up there. Yeah. Okay, so that's the 18-foot ceiling right there. So the nice thing about it is that the device has the ability to do real-world metric capture of your environment. Let me switch to another demo on this device. Okay. Let me make sure this is the right one. Yeah, so part of our Unity SDK is a set of sample code. So this is the completely out-of-the-box Unity AR sample code. And what it does is it uses some of the data that you just saw with measuring environments. What we can do is I can just tap on the screen and leave a marker on the ground. But what's cool is that it uses the depth sensor. So if I point at this wall, it knows that that surface is vertical. And it leaves the points on the ground as they are. Or I can go around and put little markers around the edge of this table, like this. Right. So let me show you another app which kind of shows you a little bit about what's going on underneath the hood. So this is actually two of our Unity samples just put together. One we have real-time meshing, and the other one is AR overlay. And so what this is showing you is actually a real-time 3D mesh that's being built of the stage in real time as I walk around. So this mesh is available to you as any mesh that's in Unity. And the nice thing about it is that all the physics collisions and colliders are also updated. So if I want to, I can throw balls and they'll bounce off the tables and bounce off of the walls like that. So you don't necessarily have to render the mesh. You can still hide the mesh and all the physics will still persist. And you could use this for path planning for characters so they can actually walk through the walkable areas of your hallway. Okay. Let me boot up this other demo because it takes a second to boot. One of the demos that I said I would show you earlier was a partner app made by Partner, by Elemental Studios. And this is basically a virtual showroom app. So it turns on the camera just like the previous apps you saw and says, place your bike somewhere. So I'll place that bike on the stage like that. And if I want to, you can imagine if you're shopping for a bike, I want to reconfigure the frame. Tap on the frame, and it'll give me a few different options. Let me go with this red one here. If I tap on the wheels, I can choose different rims. And the nice thing about it is that I can actually get down and get right up close to all these different components. I can look at the individual chain links, or the tread on the tires, or the suspension, and look at it from different angles. You can also see that the registration is reasonable and stays on the stage. Now, while I did show you mostly AR-based apps, you don't have to use it in AR. You can use it in handheld VR. We don't actually have a good name for this yet, because when we say VR, people frequently think the head-mounted version. But you can still use the device as sort of a magic window into the environment. And so this is a Poco Echo, done by Possible Games. And it takes a little bit of time to load, so So if you haven't played Poco Echo before, as I mentioned, it's kind of a musical puzzle game. And this is just using the device as a camera controller. And there's a little character right here, whoops, right there, that you have to guide through the world. So you tap on the ground, and he'll kind of admire himself in the crystals for a little bit, right there. You have to wait for him. But then this puzzle indicator will pop up, and I have to tap it. Now you can see this camera overlay that has popped up. And it's basically now I'm in sort of a photo capture mode. And there's these three symbols on the left. This line with a circle, the wiggly line, and this target-looking thing. And what happens is that there are these three targets around the map, and you actually have to position yourself so you can take a picture of all three at the same time. So these little highlighter indicators give me a clue as to where they are. So there's that symbol, and then there's that symbol. So let me back up, make sure I get all three in the same picture. Oh, there we go. Okay, and when I do that, this button gets enabled, and he can progress through the map. I just tapped on the button, and this platform came up, and now I can progress. Like that. So this is just a new, another way of using the same simple motion tracking mechanic to turn the physical space of your environment into a game. Now we have a lot more demos, but unfortunately due to time, we'll sort of have to cut those short. So just to sort of recap, the technologies that we're working on for Project Tango help people find their way to new spaces that they've never been before. You can use the sensors to actually transform public spaces into gaming arenas. If you want to turn your house into a digital playground where I've built a castle in my living room or built a moat in my bedroom and I'm going to attack my brother's fortress in his bedroom, that's actually completely doable with the tracking sensing and sensing technologies in these tablets. And you can actually get up and walk around virtual stories, whether or not they're in your hand or on your headset. The tracking capabilities allow you to get up and walk around without any tethers or wires. And of course, we also see the growing enthusiasm for augmented reality. And while Google Glass was perhaps an early attempt at it, what this technology allows you to do is essentially register virtual content to the environment. And you can actually see through the physical boundaries that you have around you. So we have sub-millimeter tracking in real time, room scale sensing. There's no wires, no beacons. All we require is light. Lights to be able to see the environment just as you would if you walked into a new space. So all of the things you just saw today can be done on the Project Tango tablets that we've been giving out today. If you weren't able to get one, you can go to our website and order it. There's no more restrictions, and we actually have some international countries available already. And we started working with Qualcomm and Intel to build hardware reference designs to get it into a future generation of phones, which is what we think would be really exciting once we have it in everyone's pocket. Unfortunately, we can't talk about any schedule or details about when these products will come to market, at least not without some NDAs, but we are working with OEMs to look at when a consumer market scale product would come to be. And we want to help. This is a new platform, and just like any new platform, it's going to be largely defined and shaped by content. And so we're actively looking for really good content partners that want to explore this new genre of gaming. And if you actually think about it, everything I just did on this stage was largely procedural. So if you actually want games that actually react to the environment directly, there's new types of game mechanics that will have to be invented. So we do a few things to help that. We have regular on-site workshops at Google. We have had a contest, and we're likely going to do more of those. We also are happy to help you promote either new or existing IP of yours. We know that Project Tango will not be the mass market volume of products in a super near term, but if you have a Tango-fied version of your IP that you're willing to put on our apps, we're happy to share any press that we have with that to promote your mainline mobile IP. We're also interested in helping you find clients or partners to work with that might give you new business. And we also are interested in finding some partners that we might be willing to do direct funding or stipends to help do prototype games. If you're interested in any of these, please email us. We also have a web page which will link to some communities so you can find other people who are working on Project Tango, as well as subscribe for updates and news events. I see a lot of people with cameras out, so I'll just leave this up. The last slide was just a thank you slide, so thank you very much. Any questions?